on page 362. And we are going to discuss the properties of exponents. Start by looking at some properties that we've discussed previously. Exponents are used to indicate powers. The properties are listed below. You are to assume throughout your work that no denominator is equal to 0 and that m and n are positive integers. The first thing we need to go over is a to the 0 power. What happens when you raise any value to the 0 power? What's a to the 0 power equal? Who remembers that? 1. That is true as long as a is not equal to 0. Okay? A to the negative n power. What do you do when you have a negative exponent? What does it tell you to do? It doesn't really have anything to do with negative numbers. What it wants you to do, it wants you to move that to the bottom or to the other part of the fraction. Okay? So it's a to the negative n is equal to 1 over a to the n. If I had 1 over a to the negative n, then I would move it to the top part of the fraction. I wouldn't need anything underneath it. So it's not necessarily moving it to the other part of the fraction, not necessarily up or down. What if we have a to the m times a to the n? What do we do with the m and the n? When the base is written twice, you add them together. Suppose we have a to the m over a to the n. If it's involved in division, then you subtract them, and it would be the top exponent minus the bottom exponent. Okay, if I have ab raised to the power of n, then this is like having the distributive property. The n would affect the a and the b. If it's written in fraction form, the same thing applies. A to the n over b to the n. If we have a to the m raised to the n, if we have one base but we have two exponents, then you don't add them together. In this case, you multiply the exponents, and it's a to the m times n. Now, we've done all these before. We're going to start putting problems in there with have numbers. So let's look at this example. Example A. It says 7a squared times negative 2a to the negative 5th. The first thing I would do is check to see if there are any exponents outside of the parentheses. And we don't have any. Okay? We don't have any. So the next thing you need to do is you need to start multiplying those things that are alike. So you can multiply the 7 and the 2, and what's that going to give you? 14. Now what do you do with a squared times a to the negative 5th? This is what this means. A squared times a to the negative 5th. I've multiplied the 7 and the 2. Now I've got to do something with these a's. Well, which situation does that look like? It looks like this situation right here. A to some power times a to some power, and you add those together. So I want you to add those two exponents together. Now when you add 2 and negative 5, what does that give you? Negative 3. So this is 14 times a to the negative 3. Everything's good except you cannot leave a negative exponent in a problem. So what is it that you have to do to that to get it changed to a positive exponent? What happens when you have a negative exponent? They want you to move it to the other part of the fraction. Now, the negative 3, is it attached to the a, the 14, both, or only one of those? only attached to the A. So that's the only part that moves. Okay, so this final answer here is 14 over A to the third. That's your final answer. Had it looked like this, where 14A was in parentheses and the negative 3 was on the outside, then it would have applied to the entire problem, and it would have been 1 over 14 to the third A to the third. You would have moved it to the other part of the fraction, dropped the negative off the exponent, and it would have affected both parts. But we didn't have the parentheses there, so in this case, it's only affecting the A. Any questions on that example? Alyssa?
Where did that other A go?
Which one?
At the top of the problem.
Here?
Above that.
Above this one?
The A side. On the other side.
That A? That's like, okay, let me change that to 1.
Okay.
This is problem 1. Example A. It was not a good way to start the problem if you're going to use A as the problem number and then use A as the variable, especially on the first day back after the break. We ready for the next one? Okay. Number 2. Number 2 says negative 4x squared times negative 2x to the negative 2. This is problem 2 from the homework. I'm just skipping around doing some of these. So what happens when we get ready to multiply? We need to multiply the parts that appear to be similar. So I'm going to multiply negative 4 times negative 2. And what's that going to give me? 8. And then you have x squared times x to the negative 2. So what you need to do now is you need to combine the exponents on the x. So x squared times x to the negative 2, you're going to add those together. What do you get? X to the 0. What is the value of x to the 0? 1. So this is really 8 times 1, which is 8. This is another example. It says negative 2 times x to the negative 1 times y squared all cubed.
So can you write this down?
I would. Now in this problem, the 3 that's on the outside gets used by every member on the inside. So it's almost like you're distributing. That 3 affects the 2, this one, and this one.
Wait, hold up. Where does negative 1 come from?
This negative 1 is the
Okay.
exponent.
Okay.
So the first one I have is negative 2 to the third power. Then I have x to the negative 1 raised to the third power. Then I have y squared raised to the third power. So that 3 affects every single thing. Well, what happens when I multiply negative 2 together 3 times? What do you get? Negative 8. What about x to the negative 1 raised to the third power? When the exponents are written, when there's 2 exponents and there's only one base, you multiply those exponents together. So that's going to be x to the negative 3. The same principle applies here. Y squared raised to the third power. You're going to multiply those exponents and it's going to be y to the 6th. All is good except I cannot have a negative exponent in a problem, so the part with the negative exponent has to be moved to the other part of the fraction. And that is just the x and its exponent. The 8 and the y stay put. Okay? Any questions there?
Okay, so why does the y stay put?
It has a positive exponent, so I don't do anything with it.
Alright.
And the negative 8 had a positive exponent. You can't see it, but what's written there by the negative 8?
1.
That's a 1. Okay, next, this is another example.
So basically everything is positive goes on top?
No, everything that's positive stays put, and everything that's got a negative exponent moves to the other part of the fraction. Most of the time, it starts at the top and moves to the bottom. But remember, what if I wrote this? 1 over negative 8 x to the negative 3 y to the 6. The only part that would need to be moved would, again, be the x to the negative 3. So that's why I can't say the positive part always stays in the top. It always stays where it is. And things with negative exponents have to move across the fraction bar.
All right.
The next example says 2ab to the 5th c squared over a to the 3rd b c squared. We have to simplify this piece by piece. Okay? Is there a whole number, coefficient, other than 2 in this problem? What's on the bottom that you don't see? A 1. Can we do anything with that? No. It's just that part stays the same. So I know that I'm going to have a 2 right here. Next, I want you to focus on the a. How many a's do you have in the top? 1. How many a's do you have in the bottom? 3. You subtract their exponents. Okay? Now, 1 minus 3 gives you what? That'd be negative 2 in the top if you did 1 minus 3, and you'd end up having to move it to the bottom. What if you did 3 minus 1? What would you get? 2, and you just leave it in the bottom. How do you know whether to do the top minus the bottom or the bottom minus the top? I would subtract so that my answer turns out positive. Therefore, your whatever's left is going to go wherever you had the most. So this one's going to be a squared in the bottom. Okay, 3 minus 1 is 2. Put your answer back where the biggest exponent started out. What about the b's? b to the 5th over b to the 1st. When you simplify that, what are you going to get? b to the 4th. Are you going to put that in the top or in the bottom? In the top. Why does it go in the top? Because you had more b's in the top to begin with. What about c squared over c squared? Well, what's 2 minus 2?
0.
And something to the 0 power is 1, so it's really not even worth, you don't even have to write it down. So my answer to this problem is 2b to the 4th over a squared. Questions on that one? Okay, the next one I want to work is number 6. And this is part of the homework, so write it down as we go. 6 x to the 7th y to the 5th over 3x to the negative 1. Well, let's talk about 6 and 3. What can you do to simplify 6 and 3? It's just like simplifying any other fraction, and 6 over 3 reduces to what? 3 goes into 3 once, goes in there twice, so that part of my answer is 2. Any question on that? X to the 7th over x to the negative 1. Okay? The easiest way, or the way that my brain sees that problem is I look at that and I think to myself, x to the negative 1 is in the wrong part of the fraction. It really needs to be moved to the top. So this really ought to say this. Then the x's, when they're in the same part of the fraction, instead of subtracting their exponents, what do? You add them together, so this becomes 2x to the 8th. Y to the 5th doesn't really have anything to combine with, so that's my answer. Let's do 11. 2r to the negative 1 s squared t to the 0 all to the negative 2 power over 2rs. That negative 2 affects everything in the top. So it's 2 to the negative 2 power, r to the negative 1 to the negative 2 power, s squared to the negative 2 power, t to the 0 to the negative 2 power, over 2rs. Okay, 2rs is in the bottom. I'll write it over there. Now, I'm going to go through piece by piece. What do you need to do to 2 to the negative 2 power? Since it has a negative 2 as an exponent, you need to move it to the bottom, and you drop the negative on the exponent. So that means that 2 squared goes in the bottom now. What about r to the negative 1 to the negative 2? What's that going to be? When you multiply those two exponents together, what are you going to get? You're going to get r squared. The two negative exponents are going to multiply and become a positive. What's going to happen when you do s squared to the negative 2? When you multiply those exponents together, you're going to get s to what power? Negative 4. So it's going to go in the bottom, and it's not going to be negative anymore. It's going to be s to the 4th. T to the 0 to the negative 2. What's 0 times negative 2? So this is still t to the 0. What's t to the 0? 1. Do I need to write times 1? Not necessarily. So that's just kind of, I've just done away with that. So here we go. Let's clean the bottom of this up. 2 times 2 squared. What's 2 squared? 4, and 4 times 2 is 8. Does r combine with anything? You got that r in the bottom, and you got r squared in the top. What do you do with those? Since one's in the bottom and one's in the top, you need to subtract them. What's 2 minus 1? 1, and your answer should go in the top. Okay, s and s to the 4th. What's that give me? S to the 5th. So this is my answer right here. Any questions so far? Okay. I want you to do 1 through 24 all. Of course, I've done a few of them. I've done number 2, number 6, and number 11. This is on page 362. If you get stuck on one, ask me about it, okay? Because this is just a review page. This is just a review lesson. This is you're preparing us for chapter 7.